Hello guys, my name is Engineer Holiday. We want to talk about, we want to solve this problem on mathematical induction. And this problem is all about proof. This equation itself is the Moivre's theorems. And we want to prove whether the equation is mathematically valid. Now, let's start with what is step one. Step one says what? That show that what? It is true. Show that it is true for n equal to 1. And they even told us that for positive integers, n greater than equal to 1. So well, let's put it, I mean, so put 1 here, put 1 here. Let's see, is it going to give us the same thing? Let's see, that is cos what? Theta plus I sine theta all raised power 1. Anyway, you see n, put 1. Then equal to what? Cos what? 1 theta. 1 times theta is what? Theta. Plus I sine 1 times theta is theta. So that one is correct first because anything raised by 1 is still 1. Step 2. Step 2 is what? Assumed that it is true. We assume based on what? Step 1. If step 1 does not hold, you cannot go to step 2. Assume that it is true for n equal to k. That is to say that this one now is now based on the fact that it is true for n equal to 1. We assume that it is true for n equal to k. So anywhere you see n equal k, so cos theta plus I sine theta all raised by what? K equal to what? Cos k theta plus I sine k theta. Now the next step which I'm going to take now is to what? We now see step 3. Based on the assumption in step 2, show that it is true for n equals to k plus 1. Now, this is where the last step is, where we want to conclude this particular solution. This last step is very crucial and therefore you should be careful. Now, you are going to have cos theta plus I sine theta all raised by what? K plus 1 is equal to what? That means anyway you see n k plus 1. Now equal to what? Cos k plus 1 theta plus I sine k plus 1 theta. Now this is what we want to prove. We want to prove whether, that this one is equal to this. That's what we want to show now. We want to show it. Now how do we start? First of all, we'll pick the left hand side. Let's pick this one now. In this kind of solution, pick the left hand, which is cos theta plus I sine theta all raised power k plus 1. And if you remember vividly, this one now is like indices where we have a raised by k plus 1 is same as a raised by k times a raised by 1. So what is the a there? A is what? This like the base and this is the power. So lots of indices. Now what we want to do now we are going to apply it now because theta plus I sine theta all raised by k then times cos theta plus I sine theta all raised by 1. And anything raised by 1 is t, that means so no need. Now what we want to do now here is to what? Write this one as what? Cos theta cos k theta plus what? I sine k theta according to his theorem. We want to really know whether it's valid. Because if it is valid, then that will lead to this. That's what we want to prove now. cos theta plus I sin theta. So according to the Morgan's theorem, this k will multiply the theta, and that's what we have done. Now let us now use a mathematical concept that we all understand by opening what? A bracket. This multiplied by this, we are going to have what? Cos k theta cos theta. This multiplied by this again, I want to have what? Plus I sin theta cos k theta. There will be this one now multiplied by this, we're going to have what? Plus I sin k theta cos theta. Then we multiply the last one, we're going to have what? Plus what? Plus I sin k theta sin theta. Sin k theta sin theta. Now after doing that, if you remember, let us collect items. This one is complex number. Let this one, this one will be I square. Because this times this, I times I is I square. Then sin k theta times sin theta is what? Sin k theta sin theta. So I square. But remember, I square is complex number which is equal to -1. I don't know whether you still remember. Your complex number is what? Because I is square root of -1. Then I square will now be what? Square root of -1 all square, which equals -1. Therefore, if you understand that, that means this one now because k theta cos theta plus I sin theta cos k theta plus I sin k theta cos theta minus, because this I square now become minus sin k theta sin theta. Now, using identity, collect like them first before we get. Let this one and this one come together. So now because k theta cos theta minus, let's bring that one out, then this one close, sin k theta sin theta. Then the I is common on this one. I is there, let's bring it out. Open bracket, factorize I out. Sin theta what? Cos k theta plus what? Sin k theta cos theta. Now, if you remember identity very well, and you could recall that what? Cos A plus B is equal to what? Cos A cos B minus sin A sin B. Sin B. And another one again is that if you have also similarly we have sin A plus B, so that was sin A cos B plus cos sin B cos A. So this one will be used for this, which means that all this one will be reduced to what? Cos, what is our A now? This is A and this is B. So now be what? Cos A, that means A is what? K theta plus theta. Everything here. Don't forget that what? Because K theta is our A, K theta is our A, B is theta. You hear it now, is what? K theta is our A, B is theta. So it's due to this plus I. Now all this one now, this is our A, this is B, this is A, this is B. So if you now check very well, you see that this one will now reduce to what? Sin what? Theta plus K theta. Now what does it mean now? It means that we factorize theta out. Theta is here, theta is here. We're going to have cos K plus 1. Then if you bring theta out, what will be here? K. If you bring theta out, what will be here? 1. So if you multiply back with 1 times theta is theta, theta times K is K theta. Plus similarly, you are going to have it on the other side. You would have K plus 1 theta. Now, if you check what we have proved now, that is to say that what we started with was this. That is to say, this particular one is the same thing as what? Cos theta plus I sin theta all raised to power k plus 1. That the movements assumed. Right. So this theorem is not assumption again. It is now valid. So the proof is valid. So we have proved the correctness of the equation, and I believe that you enjoyed the class. Thank you. God bless you.